All right. With segment two, we'll pick up where we left off with the plum pudding model. Basically, on the plum pudding model, what we're talking about is how most people don't know what plum pudding. It's a British thing. Um, I like to think of it as chocolate chip cookie dough. You got the electrons there. The little dots are going to be your chocolate chips. Those are the electrons, negatively charged. And then it's sitting kind of in this cookie dough that is all positively charged. It kind of matches out and cancels out the negative charge of the electrons. So it's neutral. And that's his plum pudding model. That's J.J. Thomson. Until then, we get to Rutherford, who comes along. And basically, what Rutherford gives us is the nucleus. We knew there had to be a positive thing. Okay, there had to be positive because we had negatives. And basically, how he did this was through the gold foil experiment. On the gold foil experiment, basically, he's doing a radioactive substance, so he's shooting radioactive particles through this gold foil, which he made as thin as possible, which he thought was 1 atom thick, but it was probably a couple of atoms thick. And what he assumed, if it was, as Thomson had said, that if it was this plum pudding, that all of the particles would go straight through because that electron is so small and doesn't have a lot of mass that it wouldn't be enough to push these heavier radioactive alpha particles out of the way. So they would all just push right through it. That's not exactly what he found. What he ends up finding is that most of them go through, but some of them, as we look at here, if we see, are deflected back. Very few of them. Most of them still go straight through, which tells us that most of the atom is kind of that empty space, but that positive particle that's deflecting the alpha beams is what ends up being very dense. Okay, a very heavy particle that was enough to stop this beam and deflect it. So that's where we get the very dense, positively charged nucleus that Rutherford comes up with. So as we said, small volume, big mass, which then gives us a very big density. And it's basically what our nucleus is. So we got a nucleus now, and it's not until Chadwick comes along, who's not really given here, but Chadwick discovers the neutron, which was probably one of the hardest particles because it doesn't have a charge. But we have a positive center, and then we have these negative electrons outside of it, which brings us to Bohr. Bohr used what was kind of called a planetary model with his that said the electrons move around the nucleus like planets move around the sun. And we drew a few of these in class, and it gets talked about in some of the different additional exercises, how the first energy level could hold 2 electrons and then 8 and so on as you go. And we made a few of these Bohr models, basically giving credit to Bohr in the fact that the electrons do move in different orbitals in energy levels around the nucleus. And then last of all, which doesn't come on until later when we talk about the quantum mechanical model. And in that one, we find out it's a mathematical probability of finding the electron, and they come up with these different shapes, S, P, D, and F, spherical shapes, flower shapes, dumbbell shapes. And it's all mathematical kind of figuring out of that's where the term quantum mechanical model comes from, because it's not a model that you can really see. It's numbers and letters and mathematical equations that allow us to figure out where it's at. So kind of going from the whole idea of things, you start off where you have kind of Dalton's model and Democritus' model, where it's just a solid ball. And then Thomson adds the electrons, kind of still all positives around. Rutherford's model gives us the fact that there's a nucleus, but those electrons are scattered all throughout, kind of away from the nucleus. Bohr model, which gives us kind of that planetary, how they are moving around the nucleus, and then eventually to this probability of finding the electrons, which is our quantum mechanical model. So that's the end of kind of this beginning first little section. If you need any help, like I said, look at your individual additional exercises, videos, handouts that I've included. If there's any questions, just feel free to email. It's mark.boer@addisonschools.us.